Hi, gang. Math 6610. Sorry for the abrupt ending in the previous video. Anytime that happens, sometimes I'll recreate the instructional video, but sometimes it's just not worth it. So what I've done is caught up. Anyway, I had a technical glitch and something crashed, and so here we are, right? So what I've done is I've installed the two-way ANOVA data set. Just as before, I have subtracted out lines 3 and 11. Now, notice I did this a little different previously because my data set that I'm manipulating is called data. So I always put the name of the data right there. Don't forget to attach it. Otherwise, you're going to be doing calculations on the data set that you were manipulating. And then I just ran table A and table B just to show you that we have an unbalanced design. Now, again, order matters in an unbalanced design. Model 1, you can see that we have, and again, it doesn't affect the interaction, but for the main effects, when I enter factor A first, factor A is not statistically significant, but factor B is. And if I enter B first, then both main effects are statistically significant. The main effect A is statistically significant at the 0.05 level, and B is statistically significant at the 0.01 level. All right, you might say that's a little wacky, that um, the dynamics of the results can completely change based on the order. And I agree with you. So what do you do about it? Well, first of all, let's understand what's happening here. R is using what's called a type 1 sum of squares calculation method. I think I talked about that a little bit in the previous video. It's kind of like a stepwise. For example, this model right here, it will put the the main effect A in the model and then calculate B based on A being in the model. So it's a sequential approach. Same thing down here. B is in the model. The type 1 sum of squares for A calculation is based on B already being in the model. Well, what we need is we need a way that we can calculate not in a sequential method, but more just kind of mashing both variables into the model at the same time. And it turns out this is really easy to do. Just install the car package. And there's a command, ANOVA, with a capital A. So I'm going to do model 1, but I'm going to do type sum of squares calculation equal 3. So you'll see I get this output. I kind of like this a little better because it gives you the intercept sum of squares, which again kind of gets you focused in understanding that ANOVA techniques and regression techniques all meet out there somewhere under general linear model commands. So I can put a type 2, or I'm sorry, model 2, and you'll see that my sum of squares calculation for A and B are the same. Again, the interaction doesn't or isn't affected. So this would be something that if you're in your master's thesis, you're analyzing your data and you have an unbalanced design, you need to tell the reader that you, of course, used R to make the calculations and that the sum of squares calculations were based on a type 3 sum of squares calculation method. And that would need to be referenced somehow, some way. I think probably one of the best resources is Fields Discovering Statistics with R. So you could cite that. I'm sure it's cited in there somewhere. All right, gang. Should we get into more? Nah. Yeah, I'll tell you what. Let's get into a little bit more because this will be a really short video. So let's go back up to the original data set So I'm just going to attach data and add data, and I want to just take a look at just our model one, right? So I believe, I just want to make sure I'm not doing something goofy here. All right, so we have our original data set back where we have a balanced design. So what we have going on here, again, the interaction effect is not statistically significant, so the main effects would get our attention. So I would want to rerun the model with only A and B as main effects, not looking at the interaction. Why? Well, the interaction isn't statistically significant, so it's not giving us any additional information aside from the main effects. So the new model, we would focus on A and B, and since A and B are both, so A1 and A2 are, we have two levels, so we'd focus on a independent samples t-test, and B1, B2, B3, so we would focus on an ANOVA. Now, something you can do that's kind of cool here is to get into what's called the Tukey HST, and we can do this for, let's just do it for the new model, and I'll actually go back up and do it for the model as well. And what you'll see it does is it compares the output for A1 and A2 comparison. So again, we have statistical significance, right? And then it'll conduct an ANOVA, or pairwise comparison for an ANOVA, and it tells us that the reason we get statistical significance for the main effect B is because of the B3-B1 comparison and the B3-B2 comparison. The B2-B1 comparison is not statistically significant, so that is not contributing to this main effect being statistically significant. Now, I think this gets a lot more interesting when we leave the main effect, or I'm sorry, the interaction effect in. So I can just run a Tukey HST for the model up here. We call that model one because it has the interaction in it. And I think this is a really cool output, because what it allows us to do is it allows us to look at the comparisons of each of the cells. So it compares A2B1 with A1B1, A1B2, A1B1. And as I look down through here, I can see that what grabs my attention is this comparison, and this comparison. So really the three that emerged up here, right? The main effects. Now, when you get down here, you can get into some of the interactions as well. So if your interaction had been statistically significant, then we could have got into the difference in the marginal means of the interaction. So I think we run into that in the next video. So anyway, post-hoc comparisons using the Tukey HST, which is part of the base stats package. Very easy to do. All right, so the main thing I wanted you to see, though, here is when you have an unbalanced design, what do? Well, jump into the CAR package, use the capital A ANOVA command, and enter the type 3 sum squared calculation. All right, gang, all I got.